Hey Buffalo, my name is Itiel Shwartz and I'm here to talk about building a cloud-native company in 2020, and I'm going to share my story as the founder of Komodor, a startup that was founded in 2020. So a little bit about myself. My name is Itiel, I'm 31 years old, and I'm the CTO and co-founder of Komodor, a startup that helps companies to troubleshoot issues and problems in their Kubernetes cluster. In the past, I worked at eBay, Forter, and Rookout as the first developer, and I really love the Kubernetes community. I'm a big believer in Kubernetes and in the shift left movement, which is basically to empower developers to do like DevOps stuff. And that's pretty much about me. So what we're going to talk to you about today. So I'm going to start about building Komodor, the choices that we had to do, basically to choose the right platform, monitoring and CICD. I'm going to walk you through the pros and cons as we saw it in Komodor. And in the end, I'm going to share about wrapping up everything that we learned into very easy messages that you can take for your next project. So the journey begins in building a cloud-native company. So like I told you, I worked in a lot of companies in the past. Some of them were cloud-native, some weren't. And when we started Komodor, we tried to take everything we learned from building the previous companies we worked in and building the best company and stack from the ground up. And in order to do so, we needed to understand how we can enable the developers, the dev team, to move really fast, to be really independent on one hand, but on the other hand, because we help other companies to troubleshoot their system, we have to be we have to be fault tolerance. So we try to find the perfect combination between being a fault tolerance company and a company that is moving really fast. So the first decision we had to make is the decision of Kubernetes versus serverless versus Lambda. From the start, it was clear for us we are not going to run things on bare metal machines. We knew that we want to be cloud native as possible. And one of the things, the two predominant technologies is Kubernetes on one hand and Lambda or serverless on the other hand. We choose to go toward the Kubernetes route, mainly because it's a lot easier to run it locally. It's easier to test it, it's easier to troubleshoot, it's easier to manage the dependencies. One of the main things that are very difficult when you are working or building a new machine is not necessarily the deploying part, but also after you deploy, how do you know where the issue lies, how you can reproduce it locally. And the very cool thing about Docker is its ability to build once and run everywhere. Meaning you can run it on the cloud, you can run it localhost, and you should get the same result every time. For serverless, it's a lot more difficult running locally, and when you have dozens of different microservices or dozens of different lambdas, it's very, very difficult to understand what is going on here, to understand where the problem lies, and because of that, we decided to go all in Kubernetes. I will say that we have a lot of Kubernetes experts in the team. Our product helped Kubernetes companies to troubleshoot faster, so we are a little bit biased. But it is easier to get started, mainly if you know Docker. The second big decision that we needed to make is microservice versus monolith. I know that the current hype is going microservices, Netflix is doing it, Google is doing it. All of the big companies are taking very large services and breaking it out to smaller and smaller and smaller microservices. And now in Komodor, we started with the microservice mindset, meaning we had dozens of different microservices, each responsible for a very small portion of the job. As time progressed, we saw that a lot of the functionality is so tied between those microservices, it doesn't really make any sense having them as different services. So we started with microservices, then we moved to we reduced the number of microservices And now we have 2 or maybe 3 big monolith applications. They're not that big, but because we have like those 3 big services, it makes it easier to troubleshoot. It makes it a lot easier to run locally and to build tests for it. I will say that from like a testing and troubleshooting perspective, as long as your monolith is not huge, there is something very simple in doing like Python run versus, or Docker run versus starting like dozens of different microservices trying to troubleshoot where the problem lies between the services. So after we choose, or like while we're choosing like the microservices versus monolith, there is another very big like infra decision, and that is, should we have one repo per microservice or one very big monorepo that has all of the business logic? So I know that like a lot of companies prefer to do like per service repo. The main problems in having like per service repo is the fact that once you start having dependencies between those microservices, and I know like you shouldn't have like in a pure microservice environment, you shouldn't really have microservice that has connection or like dependency between them. But in the real world, you end up having like different microservices that depend on one another. And when this happens, what you usually do is automating, like when one microservice is updated, you update the other one repo. To solve that particular issue in Komodor, we decided on going monorepo from the ground up, meaning all of the services in Komodor are in one single repository. Each directory is basically its own microservice. So when we want to move like from this architecture to multi-repo, it should be fairly simple. And we have one directory which is shared across all different microservices. So from one hand, we have a very easy to understand file directory, but on the other hand, we do have the ability to update all of the microservices in a single commit, in a single push, what again makes it easier to test and to debug. Okay, so now let's talk a little bit about building a CICD. I know it's a very sore point for a lot of organizations, and I will tell about like the Komodor journey into CICD. So before I'm going to talk about like the technicalities, why do we need the CICD? Why does a company that is less than a year old need to invest the time in building all of this automation? Can't we just, run the test locally? And I will say that the short answer is no. Our features, your features, are only valuable when they are running in production, meaning when the code that the developer is writing is serving real life customers. And the goal of having a full CI/CD pipeline is reducing the barriers between the local environment, the local dev, into the production. Once you have a full CI/CD pipeline, every developer in your organization knows that once he pushes the code into master, it is going to go to production. This allows you to be very fast, very agile, but more than that, it allows your developers to think in advance before entering new features into the code base. Because there is no such thing as like a dead code or something like that. Every commit, every push to master is going to be in production. This will give you the ability to have more confidence because you're going to write better tests. It's going to make your developers feel more ownership, and it's going to give your customers features faster and with better quality than without this CI/CD and the old world where a developer deploy this code into production using third parties or other tools. So you don't necessarily have to have CI/CD, but if you don't have CI/CD, if your developers doesn't feel safe to deploy the code into production, you might be doing something wrong. You need to look at the system, at your CI/CD system, and to understand why are people feeling afraid deploying a code into production. So now let's go into the deep dive on how we build it. So the first thing, like I told you, we are Kubernetes native, and everything is Docker in Komodor, and that means that we go and take Docker into the extreme. And that means that even the tests in Komodor are part of the Docker build pipeline. So when I do Docker build in Komodor to one of the microservices, it runs all of the local tests as part of the stages when building the images. This allows us to have like full confidence that each Docker image has all of its test runs. And more than that, it allows us to harness the Docker caching capabilities into our CI/CD pipeline. Meaning, because the Docker layer is already cached with the test inside, we don't need to build our own caching mechanism. We just use the Docker caching mechanism. Regarding the tool, we started using CircleCI, which is really great to get started. After not too long ago, we moved from Circle into Buildkite. The main advantages of Buildkite is it allows us to write our own pipeline in Python instead of YAMLs, and because it is really Kubernetes native, it allows us to use the existing Kubernetes cluster that Komodor has in order to build and deploy the images. And that means we use our own infrastructure to build everything. This allowed us to reduce the build time, the test time, from 6 minutes to under 1 minute. And I will say, don't be afraid testing new tools if it's Docker multi-stage build, or if it's using Buildkite, which is not CircleCI or Jenkins. I can say it is really surprising to see new technologies in this space and how it helps you to save time. And like I said, like when we started talking about CI/CD, your code is valuable only if it's in production. In Komodor, we are big believers in feature flags. This means allowing to open and close features very dynamically to our users. We use feature flag with a system called LaunchDocker, which is the most popular feature flag. And when a big feature or like a dangerous feature in Komodor is introduced to production, we start by opening it up only for ourselves, then to a selected number of customers, and then to all of our customers. So using feature flags is a little bit like cheating in the CI/CD, meaning even the code is not necessarily like 100% working, or we are not that sure that it doesn't has any edge cases. It does allow us to move the code into production. It allows us to understand what is really happening, and thus allowing us to move from the local environment into production a lot faster. So it's a little bit like cheating. I think it saves us a lot of time in building a very sophisticated test cases, and instead we just go to production, we see if things are working as expected. If so, great, then we build a relevant test. If not, we understand it very fast and we iterate over it. Okay, so like I told you, the problem in building like a cloud native company or building a company that is moving really fast is not only building everything, but okay, I build it, it's now running in production, now what the hell is going on and why isn't my code working as expected? To understand it as fast as possible, we invest a lot of time in monitoring and logging tools. So I will say that the first thing that comes to mind is, before writing those tools, is to understand how is my system going to fail, basically, and what metrics, what logs do I need in order to make sure I can fix the issues as fast as possible. And that means thinking about monitoring even before like you wrote the first line of code, because after your code is in production, it is going to fail. You are going to spend a lot of time trying to troubleshoot it. And by thinking about monitoring beforehand and not after the fact, you're going to save yourself and the team hours and even days of troubleshooting and trying to figure out what exactly went wrong. So don't think about like monitoring as a time investment, as a time waster, but as a time investment. meaning it will allow you to move faster and it will allow you to reduce the time that you spend troubleshooting. So the first tool and one of the most critical tools in the Komodor monitoring toolchain is Datadog. Datadog is it's a great tool. We use it for the APM, the infra monitoring, and we use some of the synthetic testing that Datadog has. It works great with AWS and Kubernetes. We use and send our own metrics using the Datadog SDK into the APM and into the APM and into the infrastructure monitoring. It allows us to create our own alerts and monitors. And basically, most of our alerts, most of our monitoring, other than Komodor, is basically us using Datadog in order to understand what is happening. If you don't have the budget or you want to explore different tools, I will say that Prometheus is great. It allows you to collect all of the metrics in a very easy and Kubernetes native way. You can use Grafana to showcase those metrics and to use Jaeger for the APM monitoring. So if you don't want to invest any money and just use open source tools, I would recommend going over this stack: Prometheus plus Grafana plus Jaeger. The other thing that we are using is Logs.io for logs management. Again, like Kibana and Lucene is pretty much the standard in today, like logging tools. We use Logs.io instead of hosting our own Kibana solution, mainly because it's easier. We don't need to deploy our own cluster, and I will say it works quite well. Other tools that you might consider instead of using Logs.io is CoreLogix or Splunk or Loki. There are a lot of logging solutions. I will say if you are going every time doing kubectl logs or going into the server and reading the logs line by line, you are probably doing something wrong, and you should think about moving into one of the hosted solution, or at least log aggregation platform. Another things that I didn't really cover, but it's worth talking about, is the testing and the importance of tests in making sure that things are working as expected. So I know as a startup, as a new company, you don't really want to spend your time writing a lot of tests. What is really important, like I said earlier, is making sure your features are in production. So in one hand, you don't want to spend the time building the tests and building the infrastructure and so on. On the other hand, you are going to spend a lot of time making sure your feature is working correctly, and you're going to hear customers complaining, why aren't my features working correctly? So because of that, it's important to spend your time building tests from the start, but it is an iterative process, meaning you are not going to nail everything. You are not going to nail all of the perfect monitoring, testing from the ground up. And you need to understand this is a marathon. It's not a sprint. It's not that you're going to have one silver bullet and then all of your observability issues are going to be solved. After each issue that you have, after each time a customer complains, you need to understand, why didn't I understand it earlier? And what test, what mechanism, what tools do I need to add to my current stack in order to make sure I am going to know about it before the customer complains? And how can I save hours of troubleshooting into minutes? What tools, capabilities, logging do I need to add? So very important. And another trick that we are using is using Hasura and Postgres instead of having our own backend, if it's Express or Django or any of the other web servers. Hasura allows us to have our own backend layer on top of Postgres. And that means that instead of writing a lot of transformation code between the database layer and the application, we simply use Hasura, which saves us the time of maintaining our own transformation and saves us the time to troubleshoot every time there is a misconfiguration between this backend service because it is broken, because you change the schema, or because you change the REST API. So using Hasura allowed us to save a lot of time. it's like a no-code backend. Like there is the ability to extend it, but it does allow us to have like one source of truth, which is our backend, and a very thin layer on top of it, all of this database, which is our backend, which is Hasura. So it's worth checking. So to wrap everything, I just say in a very simple manner, like it is important to understand that even if it's very easy to get started, it's very easy to deploy dozens of different microservices into Kubernetes or into Lambda, you are going to face with the day two operation, basically on the day two of your application lifecycle. And because it is so easy to deploy code into production, it is that much more easy shooting yourself in the leg. So I will advise you to talk with people who just done the journey. Feel free to reach out to understand what are the best practices across the industry, to understand what are the gotchas that you have in different technologies, and to try to prepare in advance, because every minute you think about the solution and how to solve it before that will save you hours when you try to understand what is currently happening in your system. And also don't be afraid to iterate and to change direction over time, even if things doesn't work as expected. Thank you very much, DevOps Day Buffalo. It was a pleasure to be here. I can only recommend you trying Komodor if you are Kubernetes users, because we also help giving you the observability and ability to understand what is happening in your cluster in a very easy manner. And feel free to reach out over email or Twitter or LinkedIn if you have any question about building a cloud native company. Thank you very much.